So welcome to the June 2023 Algebra 2 Regents. We're going to start, this is the mock that we did. So I'm going to start out with question number 1. So I just went through and highlighted a couple of things. So average rate of change, whenever you see that, the formula that should come to mind is y2 minus y1 over x2 minus x1. So I just went ahead and color-coded things. So for the first one, 1850 to 1910. So I'm going to go ahead and label these. So x1, x2, y1, wrong spot, y2, right? So this teaches you to be careful. So we're going to take our calculator, turn it on, whenever it feels like going on. Let's go. Alrighty. And then I just start out with alpha y equals option number 1, right? So we're doing 1850 to 1910. So we have 29,860 minus 629. And then on the bottom, I'm going to do 1910, right? Minus, just make sure you're plugging everything in correctly. Hit enter. And that'll give you the answer for the first one. Now this one's a little annoying because I put it as a fraction, but you just hit math, go to decimal, option number 2, and hit enter, and it'll give it to you, right? So this is about 487. So 487. And you just do the same thing to each of the other ones, okay? So for the next one, 1990 to 2010, right? So again, I color-coded, so alpha y equals, and yes, you have to do this. There's no shortcut around this. So you go 790, 390, minus 494. So the color coding does help. 494, 290. And on the bottom, we're going to do 2010 minus 1990. Okay. And 14,805. So 14,805. And you do the same thing for each of the other ones. And the last thing you have to do is compare it. So looking at the answers to all 4 of these, the one that is the largest is 14,805. So the answer choice is number 2. Okay. Question number 2. Keyword here is which is not equivalent. Not equivalent. So the way I show you all how to do this is by plugging numbers in. So 2.1, you hit the store button, plug it in for x, and then pick another number, 3.5, store that number in for y. So that's alpha and y is number 1. You see what I'm doing? And so now you're just plugging everything in, right? So 36x to the 6th, go over to the right, minus 25y, so alpha 1 to the 4th, hit enter, and it gives you this lovely number right here. And then you plug in the expressions that are there. So the first one, right, you're plugging in 6 squared. So 6 squared, parentheses, plug it in exactly as is, x to the 3rd. Right, go to the right, close those parentheses, square that, and then we have minus 5 squared. And again, please type this in correctly. Parentheses alpha 1, that gets squared as well. And then we close parentheses and we square that. All right, and we're going to hit enter. And that does give us the same thing. So that crosses out. You're going to do the same thing for each of them. And you're going to see that 3 is the one that is different. I will prove that to you right now. So again, that's the magic number, right? Negative 663. So 6x to the 6th, come down. And then we have minus 5y to the 4th. Go to the right, parentheses, and then we have 6x. We're doing the same thing except with a plus, right? To the 6th, go over, plus 5y. Forgive me that it's taking a while, but you know what? So what, right? One more question correct. Like this, cool. All right, and that is not the same thing, okay? What are the zeros? So for this one right here, there are a couple of different ways to do this. first thing you could do is go to your y equals and literally just type the function in, right? So x to the fourth as is. You could have combined, if you could see that these are like terms, so you could have combined them. Yeah, sure. So x to the fourth, and then we have plus 3x to the third. I'm counting down 4, 3, 2. And then this is negative 19x squared minus 27x plus 90, right? So it might be a little bit less to type stuff in. And again, if you didn't know that, that's okay. You could still get the same answer, 3x to the third. I'm just saying for typing purposes, minus 19x squared minus 27x plus 90. All right, so now we're looking for the zero. So you hit second graph. And what are we looking for? Where the y's are zeros, right? So we can see right now 2 and 3. Okay, so anything that has a 2 and 3 is an answer. So those are out. 2 and 3, right? Looks like the answer choice is 4. Because it's the only one that has a 2 and a 3 in it. Okay, so I can verify that the others are true. Let's go to the negative side, and boom, -3 and -5. Okay, so the answer choice that makes sense is number 3. All right, number 4. If let's go this color. Sure. First thing we're going to do with this question is we're going to go ahead and graph this. So this is -2 and -3. So I make a point there. I'm going to go ahead, connect that to 0, 0. So we connect this as best as we can. Good. And this is -2 and this is -3. Okay, here's our theta. All right, cool. So we'll label things just because we have it here. So this is our opposite. This is our adjacent. And then the side that's missing is our hypotenuse. All right. So what are they giving us? What are they asking us to find? So they're telling us what is the numerical value of tan of theta. So tan of theta, TOA, right? So TOA is opposite over adjacent, right? Cool. We have those already, right? Opposite is -3. So I'm going to put the -3 on top. And the adjacent is -2. So -3 divided by -2, when you plug that into the calculator, is positive 3 over 2, because negative divided by negative is a positive. All right, that's not so bad, not so bad. All right, so this one, what is the range of temperatures? So this is another calculator question. So I'm a little lazy, so I'm going to just second plus, see if it does it for me. Second plus 712, and all I'm doing is I'm clearing my calculator up. So I'm going to go to my y equals here, and I'm going to type in my function. So -23 cos is right above the parentheses. And then I'm going to do alpha y equals option number 1. So we're going to do pi, which is second the up arrow. So pi over 6. And instead of m, I'm going to use x. Close those parentheses, plus 56. Cool. So now I know when I graph it, since it's plus 56, I'm not going to see anything unless it comes down to, 0 to 10 kind of thing. So no, nothing's there. So now I want to change it to make it something that's bigger than 56. Okay, so I'm going to hit window and I'm going to change my y max. And again, I want something that is bigger than 56. Let's just go 80 and see if that helps. Okay, and again, I'm just guessing it. Okay, there we go. Oh, actually perfect. So it looks like it goes, since the highest number was 80, it looks like it goes to like maybe 70, high 70s. So right off the bat, the small, right, so it looks something like this, and comes down. So it looks like this is about 80, right? And then this one, so this, none of these have 80 here, right? So the only one that makes sense is this. So let's see if this is right. So how do I get my calculator to do that, right? So I have, no, I can see that the bottom part right here, I want to look and see what that minimum is. So how do I do that? I hit second trace or second calc, and I'm looking for the minimum value. So option number 3. So I'm going to go a little bit to the left of that little valley. So anywhere to the left of it, I'm going to go over to the right of it. Keep hitting enter anywhere to the right side. And then somewhere around here, I'm going to hit enter. And then I'm going to go to where I think it is. So it's going to be somewhere right around here. Hit enter and it'll give me 33. Okay, cool. So the lowest number is 33 for a fact. So none of the other ones say that. So it is going to be choice 2. And I can do the same thing for my max, right? So I could hit second trace. Option number 4 is maximum, and I could do the same thing. Left, somewhere to the left, hit enter. Somewhere to the right, hit enter. Somewhere where I think it is, and hit enter. All right. This one, boom, 2 equivalents in a row, right? So as soon as you see is equivalent to, you could use that store button or y1, y2. All right. So I can take my calculator here. I can show you how to do this the longer way, but it's easier with the calculator. So I've already stored a number in for x, right? What is x now? 0, so I don't want that. So I'm going to do 2.1, store it in for x, hit enter. All right. And then I'm going to plug in the same thing. Instead of the a, I'm going to use x. So to do the 5th root, I see that I'm putting a 5, and then I hit math. I'm going to do option number 5, and then I'm going to do x to the 4th. Okay, so this is the number that I want to match to. So I'm going to write that number down, 3.80. So if I know it's not just x because x is 2.1. Okay, now I'm going to plug each of the other ones in. Okay, so x to the 9/5, let's see. X to the, right, alpha y equals, option number 1, 9/5. As soon as I get to that 3.080 number, I'm done. Boom, right there, right? So option number 2 is my answer. And you could plug in each of the other ones to see if you get the one that is the same, but it's not. All right. Question number 7. Exactly the same thing. So I'm going to go to my calculator here, make sure that my x is still 2.1, and it is. So I'm going to do 3i. So I is second dot or decimal, parentheses. I have ai. So I could use my xi again, minus 6i squared. And I'm going to close those parentheses and hit enter. So my magic number is negative 6.3 plus 18i. So negative 6.3 plus 18i. Do you see what I'm doing? Right? I'm writing it down so that way I get my answer correct. And so now I plug in each of the other ones. So I have 3, instead of a, I put x plus 18i. Let's see if that gives me the same thing. Nope, that gives me positive 6.3. I don't want that. So this is not it. So why don't I try the one right across from it, because it does have a negative sign. So let's try that. Negative 3x plus 18i. Hit enter and boom, right? My speculation was correct. So the answer choice is 3. And again, if I plug in each of the other ones, I'll see that that does not work. All right, cool. So that's 7 questions altogether. Next one, it says, which equation best represents the graph below? So the easiest way that I do questions like this is I literally just pick numbers, right? So this looks like a is equal to 2. So this is going to be negative 2. And this looks like c is equal to 1. And this is negative 1. Okay. All right. So then when I plug that into my calculator, I go to my calculator. Let's clear what's there. And I'm going to just hit log. So there's no base, so I don't have to hit math, log base. And then I have x plus, and instead of my a is 2. You see what I'm doing? Close those parentheses, and I do plus c, and my c is 1. All right. And then I'm going to hit graph. So I didn't reset my calculator from before. So let's just hit zoom 6. And I want it to give me like these points. Let's see. So let's see if I can even make this a little bit better. So my y min is 2, my y max is 1, 2, 3, 4, 5. So I'm going from -2 to 5, and my x min is -1, -2, -3, -4, -5. So from -5, and it looks like to 5. So let's see. So I'll hit my window and I'll match it, right? So my x min is -5. You see what I'm doing? I'm trying to get it to match exactly. My x max is +5, and I'm going to go down to my y. My y min is -2, and my y max is 5. Okay, and then I hit enter. And I want to see if it gives me the picture that looks closest to my original. Yeah, that's right. So here's my, see this? You see how the function kind of comes down like this right before -2? So if I look over here, right before -2 on my picture, it does go down. And we know that this part of the graphic keeps on going, even though my calculator doesn't show me that. Okay, and then let's see how the rest of it matches up. So my C is 1, right? And it goes a little bit above that, which it does. And it does match this picture the closest. You can plug in the other ones to see, but I'm happy and content with 1. And again, you should plug in the other ones, right? So for example, if I go here, the only difference between 1 and 2 is instead of an x plus a, it's an x minus. So I'm going to change that. It's still plus c. And I hit graph, right? And boom, you can see automatically that those two are not the same. Okay, so do the same thing for each of the other ones, right? Don't be lazy. And then we're going to go ahead and look at the next one right there. All right, so the first thing we want to do is we want to see what does this say, right? Because this is what we're looking for. So it says as x, so x is our left and right. So it says as x goes to -infinity, which means as we go to the left, then f of x, which is our y, goes to -infinity. So here's our y, -infinity is going down. So it's saying as we go left, which graph has y going down, okay? So as we go left here, right? As we go left, our y is going up. So that is not what we want, okay? Over here, as we are going left, our y is also going up. We don't want that, right? So it is not 1 and 2. All right, cool. So that means that we got to plug in each of the other ones, okay? So I'm going to go here, go to y equals, and let's plug in our function. So 5 parentheses 4 close parentheses to the negative x. And make sure you put negative, not the minus sign. And let's see what happens here. So as we go left, are we going down? Let's see. No. As we're going left, actually we're going up. So that is also not true. So let's plug in the last one. Okay, so here we have a, let's clear this, negative sign. Now we have log with a 5 on the bottom. So like I was saying before, we have to hit math and go down to log base, hit enter. Now we can put our 5, and this is negative x. Okay, so no minus signs here at all. So this has to be our answer. And it is. There you go. Look, so this is our function. It goes like this, right? Something like that. Whatever. Something like that. Yeah. So as we are going left, let me draw that better. Then our y is going down. As we are going left, our y is going down. Because look, it's going down. If I was being dramatic. So that is our answer. All right. Equivalent. Cool, right? We like our equivalents. So now I can go to my calculator. I could do this into y equals, or I can use my regular store button. So let's see if our x is still 2.1. No, x is 10. I don't know. I like 2.1 because it's so random. Store x, enter, and then this is just a matter of plugging in. So we did this a bunch of times. Let me just see if I can go through this kind of quick with you. So for the first one, when I plugged in my function exactly as is, I got 16.0881. So as I plugged in the other ones, it was not the first one because that was 45.7281. So that was not it. And then the second one was the one that matched to my 16.0881. Okay. So therefore, I know that 3 and 4 are not, but again, if you want to make sure, you could go ahead and plug it in. All right, so for the next one, we need our apps polysimult. All right, so let me just make sure that you're good with how to get this. So you hit apps, right? The only purple button that's there, and then you hit option, for you all, it should be, I think it's A. Just find polysymult 2, PLYSMLT 2. For mine, it's option 2, but it's not going to be for yours. Anyway, find it. Once you get to this option right here, you're going to want to hit option number 2 because we're not looking for roots. That was the problem that we did above. We're going to look for simultaneous equation solver. And now we look and see how many equations do we have. We have 3 equations. This is algebra 2. And there are 3 unknowns, and x, y, and z. Answers for the rest of it can be in fraction. The rest of it's fine. So I'm going to hit graph to go next. And this is where you start putting the numbers in front of the letters. So in the first one, it's x plus y plus z. The numbers in front of them are an imaginary 1 for the x, an imaginary 1 for the y, and an imaginary 1 for the z. And then the number that's by itself is 2 on the right side of the equal sign. So I'm going to press that in. And then for the second one, my number in front of the x is an imaginary 1. In front of the y, let me just go to this real quick just to make sure that I can show you. In front of the y, there's a negative 2. Do y'all see that? So I'm going to go here and put in a negative 2. Hit enter. In front of the z, there's a negative 1. Hit enter. And the number that's by itself is negative 4. You see what I'm doing? And then do the same thing for the last one. So the number in front of the x is a 1, negative 9. In front of the z, there's an imaginary 1. And the number by itself is negative 18. Cool. And now you hit enter. Don't forget to hit enter there, and then you hit graph to solve. It'll give it to you in x, y, and z form. So the x is 0, the y is 2, and the z is 0, which is choice 3. Okay? All right. So here, the roots of the equation. So let me just show you how to use the polysymbol 2 app for this. Let's go. I can hit the y equals to get back to this menu, or you can hit apps polysymbol 2 again. And we're going to do option number 1, which is polynomial root finder. Okay. So here, I want to set it equal to 0. I don't have it equals 0 here, right? So we're going to take the x squared minus 4x equals negative 13, and I'm going to move that negative 13 over by doing plus 13 plus 13. This cancels out. So I have x squared minus 4x plus 13 is equal to 0. Okay. And again, I could do this as y1, y2, but I want to show you how to use this. So we can leave it as, since this is algebra 2, let's leave it in a plus bi form. Let's leave our answer as a fraction if possible. Everything else is fine. Let's hit next. And so now you're going to put the numbers in front of, right? There's an imaginary 1, there's a negative 4, and there's a 13. So let's put that in. So 1, enter, negative 4, cool. And then the number by itself, the constant, is 13. Okay. And then I hit solve, which is the graph button, and it gives me the answers 2 plus and minus 3i. Okay, so 2 plus or minus 3i is going to be option number 1. Okay, pretty straightforward. Cool. Is equivalent. These are my favorite questions. I always look for these. Okay, so again, this is a straight calculator question, so you could plug this into the calculator. If you need help with that, let me know, but you should get choice 1. Matches with that exactly. Question number 14. So now we need to do an exponential regression equation. So I need to plug these numbers into my stat button. So stat, whenever it feels like working. Oh, I have to go back to my main and quit. Option number 6. Let's hit stat again, and I need to go to edit. And with the magic of camera, I'm going to plug the numbers in. All right, so numbers are plugged in. And then now we're going to hit stat. We're going to go over to calc, and we're looking for exponential regression, expreg. So let's find it. So the up arrow, option number 0 is expreg. And then you literally just hit enter a whole bunch of times. All right, and it gives you your function. So it tells you that your function is going to be y equals, right, 1.77 parentheses 1.18 to the x. Looks like it. Let's just see. Yep. And then it says to you, what is, according to the model, about how many followers did she have on June 1st, 2018? Okay. So this is January 1st, 2015. So how long after that, right? How many months since January 2015 is June 1st, 2018? And that is 40. So we want to plug in, no, that's 41, my bad. We want to plug in 41, so we're going to do 1.77 times 1.18 to the 41 power. And where do we plug that in? We plug that into our regular calculator. So 1.77 times 1.18 close to the 41st, because that's the number of months, and we get 1567. All right, cool. So we get 1567, but we got to remember that the answer is the number of social media followers in thousands. So I took my answer and multiplied it by 1,000. So this is 1,567,000 something, right? So since the numbers are estimated, right? Like if I went more digits instead of just two digits in each, I would have had a more clear answer. But the one that is the closest is choice 3. But let me show you what I mean, right? If I went to stat and I went to calc and I went to option 0 and I hit enter, 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 right? And as my answers, I got 1 point. So instead of rounding to 1.77, if I got a little bit closer, if I used better numbers, so I went 1.76, right? So let's just say I went 1.7679, what's the rest of it? And then 7. Let's stop at that 7 right there. And then instead of the 1.18, if I went even closer and I used 1.18483, 1.18483, and then I put this to the 41. If you're curious about how you got 41, this is January 1st, 2015, and then the end date is June 1st, 2018. So you should see that there's a 3-year jump here. So 3 years, right? 3 years times 12 months is 36. So that's 36 months. So this is equal to 36 months. And then between January and June, that's another 5. So 36 plus 5 is where we're getting the 41 from. So if I took my calculator and I got a little bit better, a little bit more exact, and I went 1.767957 parentheses 1 point, and instead of using 18, I used 18483, 83 close parentheses to the 41st power. We should see, yeah, there you go, right? And if I take my answer and multiply by 1,000, hit enter, I do get, and again, this is an estimate, so 1,850,000 is the one that is closest. All right, so that is question number 14. All right, number 15. This one I can also use the y equals button. So y1, I could plug this in, and y2, I can plug each of the other ones in and see which one matches best. I0 is the start number. So remember, we have A is equal to P parentheses whatever, 1 plus or minus R to the T. So we had that formula, or the A pert, right? P E to the RT if it's growing continuously. So yeah, well, my point was the P is the start amount. So it doesn't matter what the start amount is. Let's just say I0 is equal to 1. And so we could go ahead and plug this into our calculator. So I go like this. Let's clear what's there. So I'm plugging in 1 is my I0. E is second ln to the 3. And then I'm going to do parentheses, negative sign, alpha y equals option number 1. Instead of t, I'm going to use x over 0.6. And then I close those parentheses, and I'm looking for which one is matching, that they are about the same. Okay, so when I plug in each of the other ones, so again, I'm going to go 1 for my I0, e to the, so second ln, and I'm going to put my negative sign. Well, I should have put my parentheses first, parentheses, and then my negative sign, alpha y equals. I was wondering why that looks a little bit different. So I'm going to put x on the top, and on the bottom I have 0.18, and I'm going to close those parentheses, and I can hit graph, or I can go to my table and I can see which one looks the same or is very, very similar. All right. So that's my first one. And there's my second one. So it says as approximated by. So I'm going to go to my table here, and I'm looking for the one that has like pretty solid or similar digits. So these are a little bit off. These are also a little bit off, not by much. Let's see if I can do better. So let's plug in the next one. Could plug in all of them at the same time and see which one gives you the closest. So I0 is 1, e to the, right, and then 5t is 5x. Go down, I0 is 1, parentheses, 0.0067 to the x. And the last one is 1 parentheses. See what I'm doing? 0.0497 close parentheses to the 0.6x. And I hit second table to get to my graph. All right. So it's pretty, yeah. So it's not, so I'm looking for between y1 and which other one. And if I look, I can see that y4 is the one that is the closest, right? So this is y1, this is my y1, y2, this is my y3, this is my y4. So 3 is the one that is the closest right now. Let's see if I can go up and see. Give me 1 second. There we go. All right, so I know we're 33 minutes in and we've only hit 15 questions, but we have all 15 questions correct. All that matters. All right, doesn't matter about the time. All right, so anytime I see a question that looks like this, normal distribution, I know I'm going to have to do something with normal CDF. Okay, they give us the mean and the standard deviation. So our mean, there's two symbols for mean. One of them is an X with a bar over it, and the other one is this symbol right here, and they're telling us that the mean is 68.1. Okay, and the standard deviation is OX, and that is 3.4. All right, so I don't see any 95% here, so I don't need to do the mean plus or minus 2 times the standard deviation formula. So it looks like I'm just going to have to do a normal CDF problem. All right, so then it says approximately what percent of students would have a height less than 60, so we want less than 60, or, right, or greater than 75. All right, so the word or means to add. So let me show you how we do this. We take our calculator, let's turn it on, get out of this, clear this. So we hit second vars, and we find normal CDF, which is option number 2, and it says less than 60. So I can go 0, right? That's our small number, or I can even go negative if I wanted to. Our upper number is going to be 60. Our mean they gave us is 68.1, and our standard deviation is 3.4. Cool. Just hit enter a bunch of times, hit enter, and I get point. So this is 0.008601. Let me just make sure. Okay. And then greater than 75, right? So I'm going to go back to my second vars, normal CDF still. And now it says greater than 75. So 75 is my lower, right? So basically this is what I'm having, right? I have two numbers here. So less than 60, I found out is 0.008601. And I want to know, so this is less than 60 or greater than 75. I also want to know all of this. Okay, so this is going to be 75 is my lower. My upper, I don't know, so I'm just going to put a big number, 9999999. The mean and the standard deviation still stay the same, and I'm going to go to paste, and I'm going to hit enter. So my second number is 0.0021208, and I'm just going to add them together. So when I add them together, I'm going to get 0.029809. I could do that like this, right? So go here, hit enter, put the plus sign, and go up here, hit enter, and I hit enter, right? And so that gives me this number, and since this is a decimal, I want it as a percent, right? They told us as a percent. So I moved the decimal two places to the right or multiply by 100. So that's 2.981%, which is choice 4. Okay. All right. Not too bad. A little bit of work, but so what? All right. All right. So for this next question, we can look and see they have this two students, Marissa and Sydney. So there's a lot going on here. They randomly surveyed 100 members, and then they conducted a simulation of 500 more surveys. So they took all their data points and they put them here. And then they want to see, assuming that 43% of the senior class would be interested in being in the musical. Okay. All right. So what I did is I drew like our normal curve, our bell curve. And I know that the number down the middle, like this, is our mean. And that's nicely like about 0.43. Okay, cool. And the question says they want us to know what is the standard deviation. So let's take a look at this, right? So our standard deviation is like, if we estimate this, this is about like 1 standard deviation, 2 standard deviations, 3 standard deviations, right? So if this is about 2 standard deviations, 0.52, so 0.52 is 2 above. And then if I go on the same thing on the other side and I go like this falls about 0.32, right? So this is like positive 2 and this is like negative 2. So this is our mean. So do you see that there are, I can take this and divide this into 1, 2, 3, 4, right? So there are 4 standard deviations between 0.32 and 0.52. So 0.52 minus 0.32. So when I do that math, I get 0.20. So there are 4 standard deviations, and this is, again, this is approximation. It's closest to, right? So I'm going to take that 0.20, and I'm going to divide it by, since this is our 0.20, right? From here to here is 0.52 minus 0.32. And I'm going to divide that by 4 because there are 4 sections, 1, 2, 3, and 4. So when I divide that, I get 0.05, okay, which is closest to, it's actually right there, all right? So again, I am estimating these, but I was able to make that work. For f of x equals cos x, which statement is true? All right, so for this next question, we need to figure out what is an even, what is an odd function. So just to refresh your memory, even functions are symmetrical with respect to the y-axis. Like if I cut it along the y like a taco, it's going to look the same on the left and the right. And odd functions are if I take my function and I flip it upside down, right, like 180 degrees, it's going to look exactly the same. So that's what even and odd are. Okay, cool. So I'm going to go to my function. Let me just make sure that my calculator is up and running. All right, so I'm going to go to my y equals here. Let me just delete all of this. Reset, please. Thank you. And go here to y equals. I said to reset. Second plus 7, 1, 2. Okay. I had to give it a second. Okay, so y equals cosine of x. All right, so when I graph that, it's going to give me something that looks like this. And this function is even because if I take it and I flip it along that y-axis, then it is the same on both sides. All right, so cosine is in and of itself is an even function. So if I do 2 f of x, what that means is I'm going to go like this, and I'm going to put a 2 in front of it. So 2 cosine of x, hit graph, and look what happens. The only thing that happens to it is it gets taller. Still symmetrical with respect to my y-axis, right? So all that's happening is it's still going to look like this. Let's see if I could draw that better. It's just going to go like this, right? Still symmetrical. So this is even. And then if I go to my function again, and I go down to my y3, let me put in f of 2x, right? So that means that I'm going to do cosine. Instead of cosine of x, I'm going to put in cosine of 2x. And now let's see if that function is also even. Yeah, there you go. It is, right? So like it's still, if I take it and cut it across the y-axis, it's still going to be symmetric, right? It's still going to be symmetric. It's going to be the same on the left and the right. So choice number 1 is correct. Okay. Solution set. So I could go like this, y1, y2. That's one way to do this question. I could use the store button, store in -6, plug everything in, hit enter, plug everything in on the right, hit enter, see if they're the same. So there's a bunch of different ways to do this. The easiest of which is probably like just taking it, plugging it into our calculator. So let's see if I can do that. And if you want me to show you any of how to do these by hand, come see me. So alpha y equals option number 1. So I'm plugging in my function. Go down. Have a plus sign. And then another function. So alpha y equals. See how I'm doing this? If I'm taking the time to do this, you should be doing this as well. So this is x plus 2. And then I'm going to go to my y2 and I'm plugging in another fraction. So I have on top 6 plus 10x. And again, just make sure you're typing this in correctly. And this is x minus 5. Minus 5, close parentheses, and x plus 2. X plus 2. Okay. And then I go to my table. So what I'm looking for, -6. So let's start with the first one, -6, and I'm looking to see if y1 and y2 are the same exact. So -6 does work. Okay, so that means that this is wrong automatically. So now let's see if 5 works. So let's go here, let's go to 5. So is it just -6 or is it -6 and 5? So 5 has 2 errors, but not all errors are the same. So 5 does not work. So the only answer choice that makes sense is the first one. And since we're already there, we can check 6. This is not the same left and right, so it's not this as well. Okay, so the only answer choice that makes sense is the first one. Our equivalent, so this is another store button problem, right? Store, I think we've done this a lot. So I usually store 2.1 in for x and 3.4, 3.5 in for y, and then see which one is the same thing. And you will see for question number 20, I did do this ahead of time. Question number 20, I did get choice 4. 1, 2, and 3 are all the same, and they are all equivalent to the functions, okay? So I just wanted to show you real quick, right? So I plugged in the original, plugged in each of the other ones, and you'll see that they are all exactly the same. So choice 4 is correct. Right, so the next one, inverse, right? So we're going to take our original, y equals, and we have 2/3 x plus 1/6. And for inverse, that means that I'm going to take wherever my y is, I'm going to replace it with an x. So I'm going to have, let's see if I could write this better. Instead of y equals 2/3 x plus 1/6. I'm going to take every x and replace with a y, and every y replace it with an x. So I have 2/3 y plus 1/6. So none of those answer choices have x equals, so I need to get the y by itself. So I'm going to subtract 1/6 from both sides. So I have this cancels out. X minus 1/6 is equal to 2/3 y. To get rid of the 2/3, I'm going to multiply by the flip. So multiply by 3/2. That allows us to cancel this out. So I have y equals, cool. And then I need to multiply this by 2/3 as well. So this is going to be 2/3 x minus, and now I'm plugging in 2/3 minus 1/6 into my calculator. So alpha choice 1, right? So I'm going to do 2/3, 2/3. And I'm going to multiply this by negative 1/6. 1/6. Close my parentheses and hit enter, and I get negative 1/9. So minus 1/9. And what did I do wrong? This is what happens when you go fast, right? I'm supposed to multiply by 3/2. I multiplied it by 2/3. So this is supposed to be 3/2. So let's see, let's redo that. So this is going to be 3/2 x. So these are out, okay? And then I'm going to go to my calculator again, and I'm doing 3/2 times 1/6. So I can just go up, and instead of 2/3, I can replace this, right? And I'm multiplying it by negative 1/6 because of that minus sign. So I do 3/2, and now let's hit enter, and we get 1/4. Okay, so minus 1/4. So that is choice number 3. All right, that makes sense. All right, we're almost done with the multiple choice. Question 22. How many equations below are identities? And again, these are just store buttons, right? So here's our, so we're not going to y1 this, but you're going to store numbers in, plug in x squared plus y squared, whatever you get. You're going to do the same thing on this side, right? I feel like we did this a lot. And if they're the same, then that's an identity. And you're going to do the same thing for each of the other ones. And you'll see that actually none of them are identities. Like you don't get the same thing on the left and the right side for any of them. So this does not work, this does not work, and this does not work. So none of them are identities, okay? All right, next question. Focus and directrix. Let's get this right. So whenever I have a focus and directrix question, I will always find a sheet of graph paper and we'll graph this. So it's telling us that the focus of a parabola is 0, 6. So I'm going to go ahead and make my axes, okay? So 0, 6, right? 1, 2, 3, 4, 5, 6. There's my focus, 0, 6. I'm going to label it. Cool. And then it tells us that the directrix is y equals 4. So I'm going to go 1, 2, 3, 4, and that's where my directrix, which is a line, is going to be. Okay. The next thing I want to do is I want to find my vertex. And how do I find my vertex? By going to the point directly in the middle of that. So this point right here is 0, it's 1 below the focus and 1 above the directrix. So it's going to be 0, 5. The first number is my h, the second number is my k. All right, cool. We're getting there. So now we got to see if my parabola is face up or if it's face down. And how do I tell, right? It's in the direction of my focus. So my focus is up. So that means that my parabola is going to be facing up, okay? It's going to be facing towards the focus. It can never cross my directrix. So it's never going to look down, okay? All right. So that means that my P is equal to this distance right here, which is just 1. P is 1, and it's positive because my directrix is facing up. So then I just take my things and I plug it into my formula, right? So I have y equals 1/4p x minus h squared plus k. So I'm just literally just plugging things into my little formula right here. So I have y equals 1/4p, and my p is 1, and I'm going to go x minus h. My h is 0. I'm going to square it, and I'm going to do plus k. K is 5. So then I literally just evaluate this, right? So I have 1, y equals 1 over 4 times 1 is 1/4. X minus 0 is just x. So this is going to be x squared. And then I'm going to have a plus 5 there. Okay. And then I'm going to look and see what does that equal to? Like, is that one of my answer choices that I have? So let me just make sure that I have that. And let's go back up to my question. This was the multiple choice. So I'm going to just write down what I had, right? So I have y equals 1/4 x squared plus 5. And that's not here exactly as is. So I need to do a little bit of maneuvering. Okay, so I'm going to move. You see these? It has the y squared. It's definitely not anything with a y squared. So those are out. Okay, so then here I'm going to get my 5 over. So I'm going to do minus 5. So this cancels out. So I have y minus 5 is equal to 1/4 x squared. I have to get my x squared by itself. So what does that mean? That means that I'm going to multiply this whole thing by 4. So these will cancel out. Whatever I do to one side, I do to the other side. Okay, this is beginning to look a lot like this. So I have 4 parentheses y minus 5 is equal to x squared. Isn't that exactly this, right? Except switched. Okay, so 2 is my answer choice. All right, cool. Next one, last multiple choice. So now we're looking to see what is going on in this problem here. So I have John and Margaret deposit 500. So this is my initial amount. This is the start amount into a savings account. They continue to make, so they're going to keep going to deposit $500. So it's gonna be growing. So 500 and then 500 again. It's gonna keep going on the child's birthday, with the last deposit being made on the child's 21st birthday. It's a little bit messed up because the child turns 21 and it's like, okay, we're done. If the account pays 4%, so here's my rate, which equation represents the amount of money in the account? So what this is telling me is I'm going to have a geometric, right? I'm going to have a series, which means that I'm going to keep on like adding these numbers up, right? I want to find the total amount. So I'm going to look at my formula booklet. And in my formula booklet, I have a geometric series, okay? So A1 minus A1, right? Uh, R to the N, okay? And then 1 minus R. All right, so let's go back. All right, right here. All right, so I'm going to go ahead and put that in. So I had A1 minus A1 R to the N over 1 minus R. All right, so let's see. So our first amount is 500. So I'm going to do 500 minus our 500 again. Our R, let's talk about this. It is growing, right? It pays 4%. So from 100%, it's going to add 4% more to it. And that's going to be 104%, which I have to change it to a decimal here. So that's 2 places to the left. So my R is equal to 1.04. So let's put that down, 1.04 to the, and this is happening for 21 years, all over 1 minus our R, which is 1.04. Okay, so now I have to look and see which one matches that. So it's not number 1, number 3 is off as well. So it's between these two, but this one doesn't have the 1.04, right? So this is not it. So let's see, why is it this? Because if I multiply this, right, 500, I have that, minus 500 again, times 1.04 to the 21. Yep, choice 2. All right, so that is my part 1, like a little bit under an hour. Well worth it because every question is correct. I'll do another video for part 2.